Hello, in this lecture we will do an example problem in which we will use Ohm's law, Kirchhoff's current, and voltage laws. The objective that we are looking at is number 2, which is to be able to state and use Ohm's law, Kirchhoff's current law, Kirchhoff's voltage law, and be able to use these laws to analyze simple circuits. Let's take a look at our problem. It is assessment problem 2.6. And let's review. What is Ohm's law? Ohm's law is the voltage in an element is equal to the current going through that element and the resistance of that element. Kirchhoff's current law is the sum of current in to a node is equal to the sum of current going out of the node. And Kirchhoff's voltage law, the sum, algebraic sum of a voltage in a loop is equal to 0. Okay. In this problem, we have the circuit shown here, and it says use Ohm's law and Kirchhoff's laws to find the value of R. So we want to find the value of that resistor. All right, let's start by applying Kirchhoff's voltage law. So we have two loops. And let's apply KVL at loop 1. And our current is going into the voltage source at the negative terminal, so that's minus 200 volts. Let's set the polarity for our other elements. So this is V sub R. This resistor has polarity, we'll call this V sub 8. And so we're going around our loop here clockwise. So we come to the resistor, so that would be plus V sub R. And we come down to the 120 volts, so that's plus, we're entering at the positive terminal, plus 120 volts. And that is equal to 0. Let's simplify this. So V sub R is equal to 80 volts. All right, let's apply KVL at loop 2. We'll start at this node down here. So we're entering the negative terminal, so minus 120 volts. And we move around here to the positive terminal, plus V sub 8 is equal to 0. So V sub 8 is equal to 120 volts. Okay, so that takes care of both of the loops. Now let's, oops, oh, I have some more colors. I did not know that. Oh, no, we don't want white. Let's use green. So at this node, we'll call it A, node A. We have the current I sub R coming in. We'll use passive sign convention, so entering the positive terminal here, so we'll call this I sub 8. And I'm gonna, I'll leave it there. Across this resistor, we have a current, which I'll call I sub 24, I guess. Okay, so apply KCL at node A. So sum of current in is equal to sum of current out. And coming in, we have I sub R is equal to I sub 8 plus I sub 24. And we can define I sub 8 and I sub 24 using Ohm's law. So expressing current in terms of Ohm's law is equal to V over R. And we know the voltage at each of these resistors, so I sub 8 is, the voltage is 120 volts. So that's 120 volts, and the resistance is 8 ohms, plus 120 volts, and the resistance is 24 ohms, so I sub R is equal to, let me find my calculator here. So we have 120 divided by 8, and that's 15 amps. 120 divided by 24 is 5 amps. So I sub R is equal to 20 amps. Okay. So let's see. We know V sub R and we know I sub R. So let's use another color here and let's apply Ohm's law. So voltage is equal to IR, and we're looking for R is equal to V sub R over I sub R. And we found V sub R to be 80 volts, and I sub R is 20 amps. So R is equal to 4 ohms. Okay, I think that's all we have to do. Find the value of R. Yep. All right. We are finished.